The quality of concrete structures that you cast is only as good as the quality of the formworks that you use. The type of formworks that you use will dictate the final quality, speed, and cost of the construction. Formwork is a term given to either temporary or permanent molds into which concrete or similar materials are poured or cast. In the context of concrete construction, the molds are supported by falsework. Falsework consists of temporary structures used in construction to support spanning structures in order to hold the structural components in place until its construction is sufficiently completed and it has developed sufficient strength to support itself. Falsework also includes temporary support structures for formwork used to mold concrete to form a desired shape and scaffolding to give workers access to the structure being constructed. Formwork comes in two basic types. One is the wooden formwork. The formwork is built on site out of wood or timber and plywood. It is easy to produce and most suited for small structures, but the plywood facing has a relatively short lifespan. It is used extensively where the labor costs are lower than the cost for procuring reusable formwork. It is also the most flexible type of formwork, so even where other systems are in use, complicated sections may use it. Second is the engineered formwork systems. This formwork is built out of prefabricated modules with a metal frame and covered on the application side with material having the wanted surface structure. The two major advantages of formwork systems are speed of construction and lower life cycle costs. The conventional formwork system. Formwork system is commonly used in general construction and most suited for unsymmetrical floor framing or structures with non-modular properties. This system usually uses A-frames and other scaffolding systems as support and wood and plywood for the mold structure. This sample is a typical setup for two-layered formworks. Here is a sample of typical setup of conventional formwork more than 3 layers. Knowing the basic components and parts of a conventional formwork system is very crucial in installing and dismantling since these components are interlinked with each other. The basic parts of an A-frame are jack head, end frame, coupling pin, A-frame, cross brace, jack base. A-frames. These are commercially fabricated formworks unit made from galvanized iron. These are the main components of the conventional formwork systems and for scaffolding, with height of 1.7 meters, 1.9 meters, and 2.18 meters. End frames. Formwork units used as an extension of A-frames to attain the required height of the structure, with heights of 0.5 meters, 0.9 meters, and 0.61 meters. Cross brace. It is used to connect two A-frames or end frames together and to provide lateral support, with lengths of 1.27 millimeters, which is used for all sizes of end frame. Next is the 1.72 meters in length. It is utilized as formwork support with distance between A-frames of 1.2 meters. Then lastly is the 2.19 meters, which is utilized as scaffoldings with a distance of 1.84 meters between A-frames. Pipe clamps. Formworks unit used to connect pipes and A-frames. Fixed clamp are used to connect support pipes that are perpendicular to each other. Swivel clamp are used to connect support pipes that are at angle with each other. Coupling pin connects A-frames or end frames from the first layer to the second layer and so on and so forth. Jack head, also known as the U-head, is used to support beams or horizontal members connected at the uppermost part of the scaffolding. Jack base is used as the base support of the scaffolding system. It is threaded and comes with a wing nut for adjustment. Aluma beams are aluminum section with wooden inserts used as joist or lateral support for sheetings. Lengths available are 2,440 mm or 8 feet, 3,050 mm or 10 feet, and 3,600 mm or 12 feet with an effective depth of 140 mm and 122 mm. Aluma clips are accessories used to fix the aluma beam to the other beams or U-head. Pipe support are pipes used as shoring for formworks. This is usually retained to support the structure after the removal of the forms and during the curing period with lengths available of 1,000 mm, 1,500 mm, 2,000 mm, 2,250 mm, and 2,500 mm together with an adjustable base and head with a length of 600 mm length, which its effective height is only 300 mm long. Acro posts are pipes used as shoring for formworks. This is usually retained to support the structure after the removal of the forms and during the curing period. Acro posts can carry loads of 3 to 5 tons, with a total height of 2,700 mm up to 3,050 mm. Each formwork system has its own pros and cons, so choosing the type of system to be used can be advantageous to the contractor. The advantages of the conventional formwork system are very flexible and can be used to various applications. Transfer of formwork materials from floor to floor does not require the use of cranes. Very easy to assemble and disassembled, does not require highly trained workers. Readily available in the market. The disadvantages are dismantling and stripping takes longer and consume more man-hours. Form sheeting wastage is high. Average reuse of plywood ranges from 4 to 6 uses. Takes much storage space. In conclusion, conventional formwork systems are best when the work area is small and isolated and the shape, dimensions, and elevation of structures to be cast are variable. When the design of floor is not typical. When there is very limited access to the work site and structures to be formed. When there is no available lifting equipment.